Hey, here's some problems from 2014. Some of them, maybe we can use our calculator. We'll find out. Actually, we can use use a calculator for all of them, but as you will find out in these calculator sections, it's only about half of the problems require calculator use. So, anyway, figure above shows the graph of this differentiable function. Differentiable means there's no sharp corners or jumps or holes or vertical asymptotes. Which of the following could be the x-coordinate of a point at which the line tangent to the graph of f is parallel to the secant line through the points 1, f1, that's this, and 5, f5. Well, that should be easy enough. Looks like could have a parallel secant line. No, that's close, but no cigar. So it looks like this one. That was easy. So that's like mean value theorem light, I guess. That's like the picture version of the mean value theorem. That's what that is about. All right. Number 77. The number of antibodies Y in a patient's bloodstream at time t is increasing according to a logistic differential equation. So logistic differential equations look like dy dt, right? Usually we use time here instead of x, is equal to, if it was just, that's exponential growth right there. The difference between exponential growth and logistic growth is here we have this logistic factor. We have 1 over y over the, sometimes we use an L or a capital A, whatever you want to call it, where that thing right there is the carrying capacity. So it's got to look something like this. Let's see. So this one has t's over here. That's the wrong thing. That's just not anything remotely. That's exponential. If you solve this, this would just be like t squared. That's just like quadratic. So it's got to be, oh, and this one's missing the y there. So this is the only one that's even the right form at all, if you know what those look like. So carrying capacity here would be 5,000, and we can answer other questions about that. But that's the only one that's logistic. What's the area of the region enclosed by this graph and this one? Well, I guess I gotta figure out where they intersect, and hey, this is a calculator problem, so I'm not gonna do that by hand, because that would be crazy. So, I don't know what that message is telling me. I borrowed this calculator from Miss Hinkle, so, because I don't mind, I thought I'd do the new fancy kind, so it would match up better with you. So, if I wanted to if I want to put the little fraction thing, if I want to make sure I don't mess that up, I can do that. Plus x squared, you can do that, right? So there's my first one, and my second one, I got to that menu by doing alpha y equals, by the way. It's F1 that gets you to that menu. And then this one is x squared minus 1/3. And I'm going to graph them, see where they intersect. Looks like they intersect in 2 places there. I want to zoom in here. I'm going to do, I don't know if you know about the zoom box, number 1. That's where you get to draw the window where you want to zoom in. Put that at one corner and push enter, and then you stretch out your box from there. Of course, you could just type zoom in, but I don't really like zoom in because you don't really know what you're getting. Alright, so it looks like it's from here to here. And both of these are even functions, so you could go from 0, well, whatever. So it looks like this one's on top, this one's on the bottom, so I need to do the integral from negative whatever to positive whatever of this first one, which I put in as y1 minus y2 is on the bottom. So I just need to figure out those intersection points. So let's do that. Intersect. Close enough, should be. So the intersection is at negative 0.931. I'm going to keep 4 decimal places. times 9319. You could find that one over there. If you weren't sure that this was symmetric, I am. If you weren't, you could just find that other intersection to make sure. Alright, so now I want to do, let's go back to the home screen. I want to do math 9. I want to find this negative 0.9319. I'm going to evaluate this definite integral. 9319. I'm just finding an area, so don't get all excited about squaring these or something. This is not a volume. And since I have those things in, I'm going to use the variables menu and go ahead and, from the y variables, pick out y1 minus y2, just so I don't have to type them out again. You can type them out again. It doesn't matter. It's up to you. dx. And hopefully that will give me something that matches up to one of their answer choices. And it did. Great. So here, this looks like more calculator work here, looking at these answers. A vase has the shape obtained by revolving, oh, here we go, by revolving the curve y equals 2 plus sine x from x equals 0 to x equals 5 about the x-axis, where x and y are measured in inches. What's the volume? Okay, so I'm revolving this around the x-axis. So that's a pi r squared. And we're going from, they're just telling me where we're going from here to here. And there's my function, so this is a pretty straightforward version of this. Alright, that's it. So, let's do that. I'm going to clear out, I'm going to have to look at that last problem. So, math 9, I'm going to go from 0 to 5. I forgot the pi on there, be careful, I'm going to multiply by pi at the end. I bet you the answer is there if you forget to multiply by pi. Sine x, and then that whole thing, that's not right. I don't like where the well, okay, I think the problem is here. I need to put another set of parentheses there. I didn't like the way that was looking, so I'm going to be safe. 2 plus sine x, and then close that, and then I can close that one and square. There we go, that looks better to me. And dx, and that whole thing is multiplied by pi. 80.115, and let's see, I bet if you divide that by pi, oh no, there it is. Be careful, don't forget the pi. Alright, number 80. The graphs of two differentiable functions, f and g, are shown above. We got function p, that's the product of these two. Which of the following statements is about p prime of negative 2 is true? Well, p prime of x, using the product rule, is this, right? They take turns being derivatives. That is the product rule. Right? So, if you want to know what p prime of negative 2 is, that's f prime of negative 2 times g of negative 2 plus f of negative 2 times g prime of negative 2. So let's see what we can find out about those from the graph. First thing that I'm spotting here is that it looks like g prime of negative 2 is 0. So that means this whole thing is 0. That looks like it's got a maximum right there. And then here, f prime of negative 2, well, I don't know what it is, but it's negative, definitely a negative number. And g of negative 2 is, oh, also 0. So g of 2, oh, negative 2. Oh dear. Oh dear. That's negative 2, isn't it? So forget about that. Okay, so let's try this again. So g of negative 2 is a negative. This is a negative number. F prime of negative 2, that's a positive slope there. That's a positive number. F of negative 2, oh, that's the one that's 0, right? So that whole thing. So it is 0, but it's not for the reason that I said. So p prime of negative 2 is going to be negative, because I've got a positive times a negative, and this is 0. There you go. That's a nice kind of problem. They're really not hard if you're not afraid to just like do it and see what you can get from the graphs. Alright, this looks like maybe more calculator stuff. Time t equals 0 years, a forest preserve has a population of 1,500 deer. If the rate of growth of the population is modeled by, okay, so this is regular old exponential growth, deer per year, what's the population at time t equals 3? Oh, I guess if you plug 0... Oh, the rate of growth is modeled by this. Okay, so that means... So this is not exactly... Well, this is the derivative, so this is just a fundamental theorem then. I know that at time 0... the population is 1,500. And I'd like to know the population at time 3. So I'm going to take the integral of the rate from 0 to 3, because that tells me how much it changed. So this that I'm looking for is this integral plus 1,500. Fundamental theorem. Alright, so let's set that up. So I got math, 9. So I need to do from 0 to 3 of the function 2000 e to the 0.23 x, and then I need to add that 1,500. So 10,141. There we go, and this is probably, that's if you forgot to add the 1,500 there. Oops. Fundamental mistake of calculus. And I'm going to break this video here, and we'll continue in a sec.